Hi everyone. Today we are going to learn about electron energy levels and how are we going to apply these electron energy levels into the real world. So we learned that the electrons are orbiting around the nucleus in certain energy levels. And the people eventually figured out the electrons can move from different energy levels. They can absorb energy to go to a higher energy level or emit energy to go to a lower energy level. Sorry, here you go. So let's have a look. Okay, so electrons are orbiting around those energy levels. The lower energy level is closer to the nucleus. Okay, they can change just like you climb the stairs, they can go up to another energy level. We'll just use this. Okay, so there are two vocabularies. One is that the ground state. Ground state is the lowest possible energy level for the electrons can be. It's the most closer to the nucleus. It's the most stable. Okay, so once the electrons jump to a higher energy level, we call it excited state. The excited state energy level is the less stable level. Okay, just like we stand on the ground is the most stable, and when we jump up, we can't stay in there. We automatically come back. The electrons would do the same thing. Once they absorb energy, it go to excited state level, but it won't stay in there. It will just automatically come back. Once it come back, it will release some energy. Okay, and then we're going to go through the detail. So electrons absorb energy so they can jump up. Like when we heat it up, give it energy, it will jump up, go to the excited state and release energy when it come back to a lower energy state or to ground state. Yeah, we're going to look at this simulation to understand it better. Okay, this is basically representing like the electrons, there's only one electron. Okay, so this electron is orbiting around the first energy level, which we call it ground level, right? We can click this and let it jump, and you can tell that when we let it jump, there's an arrow come over here with different colors that represent different kinds of light. There you go. Absorb that light energy, jump to another level. Okay, but it won't stay in here. It won't stay in here. It will automatically come back. It can come back directly to the ground level or come back to a lower energy level. Okay, so that's how it come back. It come back. You can see there's a spark. That spark is so jump to a higher energy level needs energy, so it's absorbing this energy. Okay, absorbing it. And once it jump back, you can see a spark. That's representing it released some energy. We are going to see some color in with our eyes. Okay, it depends on what kind of energy it will release. Okay, let's look at more detail in here. Okay, so the energy it released, we call it photons. The photons are kind of like light energy or electromagnetic radiation that can emit when the electrons go back from a higher energy level to lower level. If the wavelengths of those light energy is match the visible light, match those kind of color, and with our eyes, we're going to see the colors. Okay, so different. So the application for this is for different kinds of elements in the world. They have different, very unique electron energy levels, just like we have fingerprints. Everyone in the world have unique fingerprints. Every element in the world have their unique electron energy levels. When they have the unique energy levels, they're going to release different amount of energy. That different amount of energy can corresponding to different color, like what we just learned yesterday. So in that case, we're going to, if we burn some kind of element, we are going to see different colors. So that's what people eventually figured out and applied it to fireworks. So when we explode the firework, we give it energy, it absorb energy, the electrons went to a higher energy level, but it won't stay in there. It come back and release some energy. Once it release the energy, it can show up as some different colors. So later, green color, red, orange. We are going to I'm going to the demo on Tuesday for you, so you're going to observe some different colors from different chemicals. Okay. The other application for this is to identify the elements in the stars. Okay. People use that, like different element can release different kinds of energy, and it relate to different like spectrum, like radiation spectrum. Like for example, different element really have a unique spectrum. We use the equipment to receive those signals, and to be able to identify what we have on, like on the moon, on the Mars, other stars, so people eventually could figure out more stuff. Okay, that's the application. Hopefully you're going to enjoy the firework videos, and enjoy your long weekend. I'll see you on Tuesday.